Alright, if you guys could please turn to 6.7, perform similarity transformations. Alright, a couple vocab terms to start. Dilation. A dilation is a transformation that stretches or shrinks a figure to create a similar figure. So, whereas before we were shifting figures, we were rotating figures, we were reflecting figures, now we're actually going to be making them bigger or smaller, but still keeping them similar. The center of dilation. In a dilation, a figure is enlarged or reduced with respect to a fixed point. That point is called the center of dilation. Now, the scale factor of a dilation is exactly what it sounds like. The scale factor K of a dilation is the ratio of a side length of the image to the corresponding side length of the original figure. Basically, it's the scale factor from the original image to the original figure to the image that you created after the dilation. Reduction and enlargement, I think you guys kind of already have an idea of what those were. Basically, if the scale factor is a fraction between 0 and 1, you're going to have a reduction. The figure is going to get smaller. If the the scale factor of dilation is bigger than 1, then it's going to get bigger. It's going to be an enlargement. Okay, so reduction gets smaller, enlargement gets bigger. All right, that. All right. Coordinate notation for a dilation. Okay. You can describe a dilation with respect to the origin with the notation x, y, kx, ky, where k is the scale factor. If k is in between 0 and 1, the dilation is a reduction. If k is greater than 1, the dilation is an enlargement. Alright, let's go on to page 2. Alright, example 1. Draw a dilation of quadrilateral ABCD with these vertices. Let's draw these vertices first. So A is 2, 0. There's A. B is 6, negative 4. C is 8, 2. D is 6, 4. Okay, so here's our quadrilateral. Okay, use the scale factor of 1/2. All right, first draw ABCD, which we did. Find the dilation of each vertex by multiplying its coordinates by 1/2. So this is what we're going to do. We're going to multiply each of these numbers by 1/2. Basically, we're going to divide by 2. So 2, 0 becomes 1, 0, because 2 divided by 2 is 1. 0 divided by 2 is 0. 6, negative 4 becomes 3, negative 2. 8, 2 becomes 4, 1. 6, 4 becomes 3, 2. And we're going to call this LMNP. Let's graph this. 1, 0 is here. 3, negative 2 is here. Oop. Negative 2, not negative 3. So this is L, this is M. 4, 1. 1, 2, 3, 4, 1. And 3, 2. That's P. Okay? So here is our image. All right? Okay, example 2. A triangle has the vertices 2, negative 1, 4, negative 1, and 4, 2. The image of ABC, of triangle ABC after dilation with a scale factor of 2 is triangle DEF. All right, so let's sketch ABC first. We've got 2, negative 1. That's A. 4, negative 1. It's B. And 4, 2. So it looks like a right triangle. Okay? Okay, so DEF has a scale factor of 2. The scale factor is greater than 1, so the dilation is an enlargement. We're going to multiply our x's by 2. So 2 negative 1 becomes 4 negative 2. 4 negative 1 becomes 8 negative 2. And 4 2 becomes 4. 8 4. Okay? So, let's graph this. 4 negative 2 is here. I'm going to call this A prime. 8 negative 2, 3, 4, 5, 6, 7, 8. It's B prime. And 8, 4. 1, 2, 3, 4. Here's C prime. So here is our image after the enlargement. Sorry, the lines are kind of crooked. Okay? Now we need to verify that these two triangles are similar. Because angle B and angle B prime are both right angles, angle B is congruent to angle B prime. Show that the lengths of the sides that include angle B and angle B prime are proportional. AB is similar to, or corresponds with A prime, B prime. This corresponds with B prime, C prime. This is 2, this is 3, this is 4, and this is 6. These, if you simplify them, are both 1/2. So, the lengths are proportional, so these triangles are similar by the SAS similarity theorem. Alright, let's go on to page 3. Find a scale factor. Okay, you are making your own photomagnets. Your photo is 8 inches by 10 inches. The image on the magnet is 2.8 inches by 3.5 inches. What is the scale factor of the reduction? Okay, the scale factor is the ratio of a side length of the magnet image to a side length of the original photo. Oh, or 2.8 inches, because that's the magnet image, okay, over 8 inches, because that's the original photo. You could use 3.5 and 10. We just use this one instead. Okay, now, I'm going to pull this over here. 2.8 over 8. I don't like this decimal inside the fraction, so I'm going to move the decimal place one place over. So now I have 28 over 80. Now let's divide by 4. I've got 7 over 20, and that can't be simplified anymore. So the scale factor is 7 over 20. Alright, I'll let you guys do the checkpoint. Let's go on to page 4. Okay, you want to create a quadrilateral JKLM that is similar to the quadrilateral PQRS, and it's shown here. What are the coordinates of M? Alright, so first, determine if JKLM is a dilation of PQRS by checking whether the same scale factor can be used to obtain JK and L from PQ and R. Okay, so these points, hopefully you guys are all able to figure out what these points are. P is 0, 3. Q is 2, 2. R is 2, 0. Okay. Now, JK and L corresponds with PQ and R. J is 0, 6. K is 4, 4. And L is 4, 0. You can kind of tell, it looks like you're just multiplying by 2 to get from here to here. If you multiply by 2, you get this. Multiply by 2, you get this, etc. So it looks like K is 2 for all of these. Because K is the same in each case, the image is a dilation with a scale factor of 2. So you can use the scale factor to find the image M of point S. S, as you can see in the diagram, is 5, 5. So M would be 2 times 5, 2 times 5, which is 10, 10. Alright, and I'll let you guys do the last one. And that's all.